Environmental sustainability is a global priority due to urbanization, industrialization, climate change, and declining natural resources. Complex environmental issues require systematic and data-driven approaches. Environmental design analysis enables simultaneous evaluation and multiple variables and process optimization with minimal resources. Methods such as a factorial design, response surface methodology, and Taguchi techniques improve efficiency and reliability compared to traditional approaches. EDA has been widely applied in waste management, pollution control, water treatment, and renewable energy optimization. Integrating EDA supports evidence-based decision-making and enhances sustainable environmental management.
We go to the case study 1 is heavy metals loading in tropical urban river, a case of industrial catchment. So the problem definition is this study addresses the issue of heavy metals pollution in an industrial area, Pasir Gudang, which faced the challenge of a lack of early detection and control mechanism. The main problem is the extent to which the discharge of contaminated waste into the Selangor and Kim River has affected aquatic life and water quality. As no scientific study have been documented in the area since the major pollution incident in 2019. So the treatment is have with for example, T1 is coconut shell activated carbon CSAC, T2 is biochar, T3 is natural sand filtration, T4 is no treatment control. So the independent variable is type of water treatment material. Next is dependent variable is heavy metals concentration in water milligram per liter. So the experimental unit is 1 liter river water sample. Replication is 5 replicates per treatment. So the total is 20 samples. So we go to the calculate F value. F is mean square within is 4.650 per 0.010 equal to 465.000. The value of F 465,000 is very large. If the F table is with degree of freedom 3 and 6 and 8, the critical value is usually around 4.07. Since 465,000 greater than 4.07, then rejecting the null hypothesis HO means that there is a very significant difference between the three species as indicated by significant value of 0.000. So, to identify specific differences between the four stations following the ANOVA, tested at alpha 0.05 have 4. So the first is station 3 is lowest, mean 2.20 subset 1. Station 2 is mean 3.30 subset 2. Station 1 is mean equal to 4.60 is subset 3. So lastly is station 4 is highest, that's mean the mean is equal to 4.90 subset 4. The third is there is a clear significant upward progression in value from station 3 to station 4.
Next is case study 2, methane emission under alternative irrigation regime in Malaysia, rice cultivation. The problem definition for this case study was traditional rice farming relied on continuous flooding, which create anaerobic soil condition that promote metagenic microorganisms and lead to significant methane emission. Because methane has a much higher global warming potential than carbon dioxide, rice paddy are an important source of anthropogenic greenhouse gas emission contributing to climate change. Therefore, improving water management practices is necessary to reduce methane emission and achieve more sustainable rice production. The treatment for this case study is continuous flooding (CF), alternative wetting and drying (AWD), mid-season drainage (MD), and the independent variable was the type of irrigation regime, and the dependent variable was the methane emission rate from rice soil. The experimental unit consisted of individualized plating tent or plot subjected to different irrigation treatment, and each treatment was replicated 5 times to ensure the reliability and statistical validity of the result. Besides that, the total degree of freedom was calculated as 12 minus 1 equal 11, and the treatment degree of freedom was obtained as 3 minus 1 equal 2 degree of freedom. The block degree of freedom was calculated as 4 minus 1 equal 3 degree of freedom, and the error degree of freedom was determined using T minus 1 and B minus 1, which equal to multiple 3 equals 6, and the mean square for treatment was calculated by dividing the treatment sum of square by its degree of freedom, resulting in 231.06, and the mean square for block was obtained by dividing the block of square by its degree of freedom, giving value is 1.49. The mean square error was calculated by dividing the error sum of square by the error degree of freedom, resulting in 0.324. Last but not least is the F value for a treatment was calculated as the ratio of mean square treatment to mean square error, and the total is 713.2, indicating a very strong treatment effect. And the F value for a block was obtained by dividing the mean square block by the mean square error, and resulting the value is 4.6.
Case study 3, a carbon neutral granular filtration system for sustainable and safe rainwater harvesting in urban area of Malaysia. The main problem in this study is the increased water scarcity in urban Malaysia, along with environmental impact associated with conventional water treatment method that rely on high energy. Therefore, a carbon neutral granular filtration system is proposed as a sustainable alternative to improve rainwater quality. In this study, the independent variable is the type of granular filtration media, namely F1, F2, and F3. Well, the dependent variables are water quality parameters such as BOD, COD, DO, TSS, NHN, and turbidity. This filtration system was tested using individual rainwater sample and replicate across 4 urban locations ensure data reliability. The results were analyzed using the one-way ANOVA, which showed that all water quality parameter record p-value greater than 0.105. There are no significant difference between the filtration media F1, F2, F3 and the control filtration UF. Analysis using the Tukey test confirmed that all filtration media filled with the same homogeneous subset, suggestion that variation in filtration media does not significant affect filtration performance. Although F3 recorded the lower BOD value at 3.44, the difference was not significant. Overall, the result indicate that all filtration media perform consistent and sustainable for urban rainwater harvesting.
Comparison for case study 1 for the hypothesis, rationale is there is no significant difference in the mean concentration of heavy metals across the 4 sampling groups. H1, at least one of the mean concentrations of heavy metals is significantly different from the others. For the statistic, F treatment, F null is 465.00 for critical value, F 0.0538 equal to 4.07. F calculated for F465.00, F table is 4.07. We reject H null. So for the conclusion, there is a highly significant difference in the heavy metal concentrations among the different sampling stations in the Selangor and Kim River. The ANOVA results indicate a very highly significant difference among the 4 study groups. This result strongly supports the rejection of the H null, confirming that heavy metal concentrations differ significantly between groups. These findings are consistent with the article, which reports that iron, ferrum, and magnesium concentrations vary greatly by station. with higher levels in industrial areas compared to upstream locations. For mean comparison shows that group 4 mean equal to 4.90 recorded the highest concentration, followed by group 1 4.60, group 2 3.30 and group 3 2.20.
Based on case study 2, this table compared the ANOVA result obtained using SPSS and ChatGPT. The comparison showed that the results from both methods are identical and confirm the accuracy of the manual and computation analysis. For the treatment effect, the sum of square, degree of freedom, mean square, and F value obtained using SPSS were exactly the same as those calculated using ChatGPT. The F value is 7.713.2, indicated the very strong and significant treatment effect. Similarly, for the block effect, the sum of square, degree of freedom, mean square, and F value were identical in both analyses, with a F value is 4.6, showing that the blocking factor also had a measurable influence. For the error component, the sum of square, degree of freedom, mean square error and were the same for the both SPSS and ChatGPT, indicating consistent estimation and experimental variability. Finally, the total sum of square and total degree of freedom were obtained identical and both methods further confirming reliability and consistency of the analysis. Overall, this comparison demonstrates that ChatGPT general ANOVA calculations are fully consistent with SPSS output, validating and correctness of the experimental design analysis. And move to the next case study.
Comparison case study 3. The table shows a comparison between ANOVA result generated using SPSS and ChatGPT. For all 7 water quality parameters, the value of sum of square, degree of freedom, mean square, and F value are exactly the same for both SPSS and ChatGPT. Therefore, all results are marked as matched. This indicates that the statistical calculations produced by GPT are accurate and consistent with the standard SPSS analysis. Based on the F value in the table, pH record the higher F value, which is 17.788, since the value is greater than critical F value of 3.49. The null hypothesis is rejected. This shows that the type of granular filtration media has significant effect on pH. For the other parameters such as NH, BOD, DO, and TDS, the F values are relatively low, indicating no significant difference between treatment groups. In conclusion, both SFPS and ChatGPT provide the same statistical interpretation, and pH is the only parameter significantly influenced by the filtration treatment. That's all for me. Thank you.